Solve the system graphically and indicate whether the solution region is bound or unbound. A solution region of a system of a linear inequality is bound if it can be enclosed within a circle, and if it cannot be enclosed within a circle, it's unbound. So we're going to determine if this one is bound or unbound. So the first step, we're going to find the x and the y-intercept for each of the inequalities. So if I let, on the first one in the blue, x plus y equals 3. If I let y equal to 0, then I have 3, 0. I let x equal to 0, then I'm going to have 0, 3. On the second equation, I'm going to do the same thing. Y is equal 0. So y is equal 0. X is going to be equal to 4. And if x is equal to 0, y is going to be equal to 2. Okay. So let's plot those intercepts. I've already plotted those. So we have two graphs. The red is the x plus 2y is less than 4, and the blue is the x plus y is less than 3. Let's use test point 0, 0 and check and see where we're going to shade. So in the first equation, which is blue, x plus y is less than or equal to 3. Now my test points 0, 0. We're doing tests. Okay, so 0 would be less than 3. That's a true statement. So on the blue, we're going to shade everything that has underneath the blue. Going to shade it good. So let's do the same thing for the red. So test point, same test points, 0, 0. So now we would have zero plus 0, so 0 is less than 4. Another less than or equal to, another true statement. So now we're going to shade everything under the red to include okay, so you get an idea. It's always good if you have colored pencils at home to do these as well. So next thing, just to see where where they're going to intersect, we're going to do simultaneous equations, and I'm going to take x plus y is equal to 3, and x plus 2y is equal to 4. I'm going to multiply by -1. I want to cancel out my x. So I'm going to multiply this whole thing by a negative. So that makes this negative. This becomes negative. Now you may have to show another step if you're using another number other than a -1. So these cancel out. I have a -y is equal to a -1. Y is equal to 1. I can take either one of those equations and substitute in y, and get x. So I'm going to use the first one. So I would have x plus 1 is equal 3. X would be 2. So I have the ordered pair 2, 1. So at 2, 1, we have an intersection point of the two graphs. Now we want to find if it's bound. We've determined that it is bound. So we want to find the solution set. Let's clarify our drawing. We're going to find the coordinates of the top left corner. So the top left corner would be, I'm going to put top left corner, since I don't have a lot of room, is 0, 3. Top left corner. Okay, the top right corner is 2, 1. The coordinates of the bottom left corner, the bottom left corner here is 0, 0, and the coordinates of the remaining is 3, 0. Okay, coordinates of the remaining connect. The top left corner is 0, 2, so I need to erase this and make a correction there. So let's redo that. 0, 2. So we are bound. Let's see what else it asks us. What are coordinates of each corner? We have those here.